Let's start the next exercise, exercise 18C. No new concept to be taught, but just let's revise the three things that we've learned in this chapter till now, which is tangent makes an angle of 90 degrees with the radius. Next, tangents from a point which is outside the circle to a circle are equal, and angle in alternate segment are equal. So let's look at the question. It says Oabc is a rhombus whose three vertices lie on a circle with center O. Okay, so let me just draw a rough diagram, helps us understand the question. So this is my center O, and then I have Oabc. And it is a rhombus, which means all four sides are equal. This is purely a rough diagram, as you can see, which means it doesn't visually look like a rhombus, but anyway, all four sides are equal, and the tangents, or rather not tangent, the diagonals bisect each other at 90 degrees. Perfect. Let the point where the diagonals meet be point O. If radius is 10 centimeter, which means 10, this is 10, which means all sides of the rhombus are 10 centimeter, we need to find the area of the rhombus. We know area of a rhombus is half d1 into d2, which is diagonal 1 into diagonal 2. Let's see how we can find the diagonals. So point number 1, OB is equal to OC is equal to OA is equal to R is equal to 10 centimeter. Point number 2, how can it be O? I've already taken as O is already given at the center, so this can't be O. Let's give it another name. Let's call it E or D. Well, let's call it E. My mistake, I've taken it as O. Can't have the same letter depicting 2 points. So this is point E. OE would be equal to OB upon 2, which is equal to 5 centimeter. So let's apply Pythagoras theorem in right triangle OEC using Pythagoras theorem. What I get is OE square plus EC square is equal to OC square. This is 5, which means 5 square plus EC square is equal to 10 square. EC would be equal to 100 minus 25, that's root 75 centimeter. Therefore, EC is equal to 5 root 3 centimeter. Now, which means a diagonal AC would be 2 times EC, which means AC would be equal to 2 times EC, which is equal to 10 root 3 centimeter. I know area is equal to half multiplied with diagonal 1 into diagonal 2, which means half into OB, which is 10 multiplied with AC, which is 10 root 3. So this is 50 root 3 centimeter. So we figured out the area. Next, if the area is given equal to something, we need to find the radius. So what we have is, let's see, area would be equal to 2 times area of triangle OAB. Yes, these two triangles are congruent. These two triangles are congruent. In this case, area is given equal to 32 root 3 equal to 2 times area of triangle OAB. OAB is a isosceles triangle because OB and OA are equal, which means area would be root 3 upon 4 into radius square, which will help us find the radius of this circle. This is 2, 1, 2, root 3 and root 3 gets cancelled, which means R square is equal to 64. Therefore, R is equal to 8 centimeter. Let's look at the next question. The next question that we do is question number 3. Two circles with centers A and B with radii 5 and 3 touch each other internally. So I have a bigger circle of 5 centimeter and then I have a smaller circle of 3 centimeter. and they touch each other internally. Okay, yeah, something like this. This would be the center of the smaller circle, and somewhere here would be the center of the bigger circle with centers A. So the bigger circle is center A, the smaller circle is center B. Touch each other internally, perpendicular bisector of segment AB. So perpendicular bisector of segment AB meet the bigger circle at P and Q. Okay, so this is the perpendicular bisector meets at P and Q. Let's just join them. So this is P and this is Q. We need to find the length of PQ. Let this point be C. Let's see how we can solve it. Point number 1, AB would be equal to R2 minus R1, which is 5 minus 3, which is 2 centimeter, which means AC would be equal to AB upon 2, which is equal to 1 centimeter. So this is 1. And number 3, AP is the radius of the bigger circle, which means 5 centimeter. So in a right triangle ABC using Pythagoras theorem, what I get is 5 square is equal to 1 square plus CP square, which means CP is equal to 25 minus 1, the square root, which means CP is equal to square root of 24, which is 4 into 6, which is 2 root 6 centimeter, which means CP is equal to CQ is equal to 2 root 6 centimeter. Therefore, PQ is equal to 4 root 6 centimeter. Done. Next question. The next question is question number 6. Question number 6 is ABCD is a cyclic quadrilateral in which BC is parallel to AD. Let me just draw the cyclic quadrilateral first. Okay, so in which BC is parallel to AD. Okay, and let's join them. So BC is parallel to AD. AD, sorry, not D, AD and BC. Yeah, ABCD in which BC is parallel to AD. Angle ADC is equal to 110 degree. Angle BAC, which means this angle is equal to 50 degree. We need to find DAC, this angle, and DCA, which is this angle. These are the two angles that I need to find. So if this is 110, this angle would be 70 degree. Why? Because this is opposite angles of a cyclic quadrilateral sum up to 180 degree. So if this is 70 degree, this is 50 degree, then this is obviously 60 degree in this triangle ABC. And since these two lines are parallel, this angle is 60 degree, alternate angles, 110, 60, 170, which means this is 10 degree. Let's just write this down. We've already solved the question. So point 1, angle ADC plus angle ABC is equal to 180 degree. Sum of opposite angles of a cyclic quadrilateral. So in triangle ABC, what we have is 70 degree plus 50 degree plus angle ACB is equal to 180 degree, which means angle ACB is equal to 60 degree. Number 4, angle ACB would be equal to angle DAC is equal to 60 degree. This is alternate angles are equal. So we've got our first part of the question. We've got angle DAC. Next, in triangle ADC, what I have is 110 degree plus 60 degree plus angle DCA is equal to 180 degree, which means angle DCA is equal to 10 degree. Done. The second part of the question also done, which means we can move on to the next question. These were quite very simple ones that we've done till now. Next question, question number 7. It says C and D are points on a semicircle described on AB as diameter. Angle BAD is equal to 70 degree. This angle for sure is 90 degree. Yes, this is 90 degree. Angle DBC is 30. We need to find angle BDC. This is the angle that we need to find. So if this is 70, then this is 110. So now in this triangle, this is 110, 30, which means this is 40 degree. Let's just write that down. Point number 1, angle in cyclic quadrilateral ABCD, angle BAD plus angle BCD is equal to 180 degree. Therefore, angle BCD is equal to 110 degree. Number 3, in triangle BCD, 110 degree plus 30 degree plus angle BDC is equal to 180 degree. Therefore, angle BDC is equal to 40 degree. Simple one, but we've solved it already. Next one we're looking at is question number 9. Show that the circle drawn on any one of the equal sides of an isosceles triangle has diameter bisects the base. Okay, let's just draw a rough diagram and see what we get from there. So what it's saying is, if this is an isosceles triangle and I draw a circle with one of the equal sides as the base, so as the diameter, then this bisects the, okay, so maybe this is a smaller circle that I'll have to do. Okay, doesn't really look like a, okay, anyway, it needs to bisect the base, that's what they're saying. Yeah, the diagram is not looking too good, but anyway, I'll move on. Yeah, okay, anyway, I'll move on from here, or maybe let me try once again if I can draw a diagram. Okay, and here I try and put a circle in here, or sorry, put a isosceles triangle in here. This is, yeah, it should, this seems like the diameter, yes, almost the diameter. Done. So this is the diameter. Let's name this. This is A, B and C. AB and AC are given equal. We need to prove that circle drawn on any one of this equal sides triangular diameter bisects the base, which means let me join AD. What we need to prove is BD. What we need to prove is BD is equal to CD. That's what we need to prove. Okay. This angle here would be 90 degree angle in a semicircle. This angle obviously is 90 degree. What else do I have? So let's just write this down, whatever we've done. I'm looking at two triangles. My first triangle that I'm looking at is this one. Let me just put it here, and then I have a second triangle here, which is here. So this is A, this is D, this is B here, this is C here. This is 90 degree, AB and AC are equal. Anything else? Yes, AD and AD are equal, which means this is by right angle hypotenuse side. These two triangles are congruent, which means BD and CD are equal. Done. So in triangle ABD and triangle ADC, what I have, point number 1, angle ADB is equal to angle ADC is equal to 90 degree. Reason, angle ADB is angle in semicircle. So that's why angle ADB is 90, and number 2, angle ADB plus angle ADC is equal to 180 degree. Reason, linear pair. So that's why both these angles are 90 degree. Number 2, hypotenuse AB is equal to hypotenuse AC. This is given. It's an isosceles triangle. Number 3, AD is equal to AD. This is common side, which means therefore by RHS test, triangle ADB is congruent to triangle ADC. What this means is BD is equal to CD, CP, CT, C. Hence proved. Let's look at the next question. The next question that we're doing is question number 11. It says AB is a chord, DOC is a line segment, O is the center, BC is equal to DO. BC and DO are equal. DO is the radius, yes, and BO is also the radius, which means is equal to the radius, and I know AO will also be equal, BO will also be equal. These are radii of the same circle. Now BOC is an isosceles triangle, so if this is 20, then this is 20 degree. Done. This angle here would be 40 degree. This is exterior angle of triangle BOC. This angle will also be 40 degree. Why? Because this is again AOB is isosceles. 80, which means this is 100 degree, which means this is 120, which means this is 60 degree. We've solved the question. Let's just write this down. Point number 1, join OB. Point number 2, OB is equal to OA is equal to OC, no, OC, OD. OD, radii of same circle. What this means is in triangle OBC, OB is equal to OC. Now this is given, which means triangle OBC is isosceles. What this means is angle BCO is equal to angle BOC is equal to 20 degree. Next, exterior angle OBA is equal to 20 degree plus 20 degree is equal to 40 degree. Reason for this is for triangle OBC. Next, angle OBA is equal to angle OAB is equal to 40 degree. Since triangle OBA is isosceles, since OB is equal to OA, which means in triangle OAB, 40 degree plus 40 degree plus angle BO, let me write it in a different line, 40 degree plus 40 degree plus angle BOA is equal to 180 degree, which means angle BOA is equal to 100 degree. Number 9, 100 degree plus 20 degree plus angle AOD is equal to 180 degree. This is angle on a straight line, which means angle AOD is equal to 180 minus 20, that's 60 degree. Done. That brings me to an end of this video. Before I leave, let me just inform you some questions which are not a part of your syllabus this year because some properties have been deleted. So question 1, question 2, question number 14 will not be a part of your syllabus. Am I marking any homework? Oh, sorry. Oh, I was looking at the wrong exercise. My mistake. I was looking at 18b. My mistake. Let me just mark which questions will not be a part of your syllabus. Question number 1, question number 10 will not be a part of your syllabus this year. Some homework question for you. Question number 8, question number 5, and question number 15. You can try it as homework. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.